Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No, we've got a mixture here. Now, Amy is going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you can ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hello, everybody. Welcome to Wednesday Night Math Night. I am so excited to be back. We've been off for a couple weeks. Priya covered me a couple weeks ago. And then, unfortunately, we had the hurricane come through. And so last Wednesday night, I was completely out of power and internet. So we are back. You notice I'm in a new location today, but that's just because of hurricane things. So we are back, and I am excited to be here, back on our Wednesday routine. As you're coming in, let me know where you're from, what test you're prepping for, and what else? What's your favorite candy? Because Halloween is coming up. What is your favorite candy to eat? Mine is definitely a Reese's. Reese's or Three Musketeers are my absolute favorite. I am from Central Florida, and I'm not prepping for a test. I'm helping you prep for your test. So let me know in the comments where you're from, what test are you prepping for, and what's your favorite candy. It just helps me get to know who's in the room, and it helps me guide our rabbit trail conversations tonight. Now, the problems that I have set are already set in stone. So I'm not changing the problems any. However, what we are doing is when I go over the problems, I like to kind of guide the conversation based on who's in the room. So, hi, Rebecca. You're from Melbourne, Florida. Hopefully you didn't get hit too hard by that hurricane. FTCE, what? Is it the FTCE K6, GK, middle school, high school? FTCE is like the umbrella name for all of the Florida exams. Oh, man. Lindt chocolate truffles. I could eat those all day. Miami, you're retaking the GK and the FTCE. Awesome. Hey, Joseph, it's good to see you. Hey, Gary, it's good to see you. Snickers, Kit Kat, Twix, Jolly Ranchers. I'm not a Jolly Rancher. I'm not a hard candy fan at all. Like, I do not like sucking on candy at all. But a girl I follow on Instagram likes to use Jolly Ranchers in her middle school class as like a reward. So that's always fun. to see. All right, let's get started. We have about 10 problems we're going to go through. As always, as I'm working out these problems, please, please, please don't hesitate to ask me any questions you have in the comments, or if you have a better way to solve it, go for it. We are all here together to help each other. I am not the expert. I am just the facilitator in the room. And if there's anything you want to see on upcoming exams, please let me know in the comment box. I'm more than happy to add that information or that kind of question or whatever into upcoming sessions. Hey, Hope, it's good to see you. All right, problem number 1. What is the unit digit of 23 to the 54th power minus 21? So in this situation, I can't plug in 23 to the 54th power in my calculator and get an answer, because I'm going to sit here and do 23 times 23, and eventually I'm going to get an error message. I'm going to get an e to the 12th power. And so, unfortunately, that doesn't help us figure out what the unit digit is. Now, before we can even solve this, we have to understand what unit digit is. Unit means the ones digit. So what is the ones digit? Is just the number that sits in that place value spot. So while this is a problem geared for my high school people, middle school, high school exam people, my elementary people, you need to know what a digit is. So when we talk about the number 3,482, the 4 is a digit. The 8 is a digit. The 2 is a digit in this greater number. The 4 is the digit that is sitting in the hundreds place. The 8 is the digit that's sitting in the tens place, and so on. So all that said, what is the digit? Well, how do we figure out the unit digit of this? I'm going to show you a little trick. So if we think about what 23 to the first power is, 23 to the first power is 23. What is 23 to the second power? Because for these kinds of problems, even if you didn't know how to solve this at first, you could start by just listing to see if you can find a pattern. So 23 to the second power, and I am going to use my calculator for this, is 529. And I'm going to keep going the third power, the fourth power, the fifth power, just to see if I can find a pattern. 12,167, 279,841, 6,436,343, and to the sixth power is 148,035,889. Is there anything you notice about a pattern in this system? The ones digit has a cycle, 3971. 39, I bet you to the seventh power, it's going to be 7 and then 1. What's interesting with exponents is it creates this cyclical pattern in the units digit. We don't see that in the tens digit or the hundreds digit, but what we do see it is in the units digit. So that said, if I have a cycle of 4, that means that if it's divisible by 4, I'm going to hit the end of that cycle. So if I do 54, because I'm doing 23 54 times. So if I do 54 divided by my cycle number, then that's going to tell me how many cycles this is going through. So 54 divided by 4, 1 minus, and I'm doing this long division. I'm not doing it in my calculator because my calculator is going to give me a decimal, and I don't want a decimal, and you'll see why in a minute. So 4 can go into 14 3 times, 12, 2. I have a remainder of 2. This is the information I need. I don't need to know how many cycles it's going through, because that doesn't help me. So we went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, all the way 13 times. So we went 52, and then now we have 21 to the 53rd power, 21 to the 54th power. 21 to the 54th power is going to be some really long number with a 9 in the units digit. Now you see why I didn't divide using my calculator, because if I used my calculator, 54 divided by 4, 13.5, well, this decimal is actually really clean. You probably could have figured it out, but that's not super helpful when we're trying to figure out where we're landing on our cycle. The remainder of 2 tells me I'm landing 2 spaces down from a full cycle. If I had a remainder of 1, it would be here. Remainder of 2, remainder of 3, and no remainder. If it was an even divide, we would land here. But that's not where we landed, so we're going to go back. Remainder of 2 means 9. Now, 9 is not the correct answer, and I should have, when I created this, put 9 as an answer, because a lot of people would choose 9 at that point, and I promise you that's going to be an answer on the exam. We are then subtracting 21. So if I have this really long number, blah, 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 minus 21, does the 2 really matter? It doesn't. What's 9 minus 1? 8. So our unit digit of this number is going to be 8. All right, let's keep going. This is really going to be for everybody. This is built for a GK, core, middle school, or high school exam. However, elementary people, you need to know how to graph and interpret graphs. So while you may not have this exact question, you do still need to be able to read a graph and interpret a graph. So let's go ahead and get started with this problem. A team of students uses flour during a cookie making competition. That sounds fun. The graph shows the amount of unused flour in grams since the start of the competition in minutes. Which of the following represents the y-intercept, and what does it mean? 140, the amount of flour used per minute. 280, the amount of flour used per minute. 500, the amount of flour they ended with. Or 700, the amount of flour they started with. So what are they asking us for? Which of the following represents the y-intercept, and what does it mean? I'm looking for the y-intercept. Now, I'm going to go off a rabbit trail for a minute to talk to my elementary people. So we're actually going to add a page really quickly here because I didn't have enough room on the other one. So when we're looking at a coordinate graph, this is your x-axis, this is your y-axis. Everybody in the room needs to know this. And if I have a line that goes like this, I know that this value right here is my y-intercept. And this value down here is my x-intercept. How do I know that? Because the y-intercept is intersecting at the y-axis. The x-intercept is intersecting on the x-axis. And then the slope is just the rise over the run, or how much is happening over a certain amount of time. So that said, if we go back to our question, even though this doesn't look like your typical graph, what it is it's just this section up here, which is why we don't see the rest of it. So they've zoomed in and are only looking in that top right quadrant, or quadrant 1. Again, another piece of information we don't need to know for this question, but we all need to know that information anyways. I'm throwing a lot of information at you. So if I were to extend these, then we would see a full coordinate graph. So which one is the y-intercept? Well, it's going to be where we intersect the y-axis. Fun fact, they gave you the y and the x. They cheated. They told you which one is the y and which one is the x. So you got lucky on this problem. If you didn't remember that, it's given. Now, which one is the y-intercept? The dot that intersects the y-axis, which is going to be up here. So we can immediately see that the y-intercept falls at 700. The x-intercept is 5. We'll talk about what each of these points means. So if the y-intercept is 700, then automatically my answer is D. I don't need to interpret it at all because they've given 4 different numbers. Now, they might give 700, 700, and then you would have to interpret it. How do I know that that's the amount of flour they're starting with? Because it's at time 0. At 700, I'm at 0 time. So the competition has started. We start to make our cookies, and everybody starts with 700 grams of flour. Then, as they make cookies, what is happening to that flour? Disappearing. It's going into the cookies, and I don't have any unused flour left. So as the competition goes, the amount of my flour is decreasing until what happens right here? I have no more flour because I've used all my flour in my recipes for my cookies. When does that happen? It happens at time equals 5 minutes. So after 5 minutes, we've used all of our flour and there's no more flour. That doesn't mean the competition is over. Maybe it's a cookie decorating contest, and so they have to decorate the cookies. So they made the cookies and they have to decorate it. Don't interpret further than what they say. So for instance, they might say, what is the x-intercept? I'm going to make up my own problem. I just thought of this. So they might say, what is the x-intercept and what does it mean? And then they might have 5 and the competition is over. And then they might say 5 and there is no more unused flour. This one right here is going to be up. You can't see it. This answer right here is going to be your only correct answer. This is one of those moments where when they say choose the best answer, it can be confusing because this really is the only answer, but it could be the end of the competition. We don't know. They didn't tell us it was a 5-minute competition. If they told us that, then it would be the end of the competition. But just because we have unused flour doesn't mean that my cookies are baked. It doesn't mean that the competition is over. So make sure that what you're interpreting in your graph is directly related to the information provided by the graph and that it's not, you're not over-interpreting the information that they've provided because of your own experience. That's what's tricky is a lot of times we take our own experiences and throw them into these problems and over-interpret. All right, that was a lot of information for this one problem, but I like to over-explain so that we can all benefit from the problem. All right, problem number 3. Oh, this one is so fun. Someone sent me this problem, and so I had to do it. Okay, a goat is attached to the corner of a square barn with a side length of 4 by a rope of length 8 outside the barn. What is the area of the region the goat has access to? Isn't this so fun? Okay, so let's start with a picture. No matter who you are, what test you're taking, you always want to start with a picture when we're dealing with something like this. So everybody needs to know these vocabulary words. We have a square barn with a side length of 4. So I'm going to draw my square barn. And it has a side length of 4. So that means that this is 4, this is 4, this is 4, and this is 4. How do I know all sides are 4? Because it's a square and a square has 4 equal sides. Then it says that the goat is attached to the corner of the barn with a side length of, or with a length of 8. So the rope is 8 units long. And then here's our goat. Okay, I'm not an artist, so I'm not going to attempt to draw a goat. Then they've asked, what is the area the region has, what is the area of the region the goat has access to? So if we have a pivot point and I have a rope, I'm going to try to like show you this. All right, here's a nice solid thing. Let's say that this is the rope and he's attached here. What's going to happen as he walks? What shape is that going to create? It's going to create a circle, okay? So if it's going to create a circle, then I can draw a circle around. Now, do not judge my circle drawing skills. This is going to be rough. So it's going to create a circle, but we have to keep in mind that the goat is eventually going to run out of room, right? So I'm going to make this a little smaller because I've drawn it way too big. So we have to realize that this goat is going to run out of room, right? So as he walks in this circle, what's going to happen when he gets on this side? He's going to have an 8-foot rope or an 8-unit rope, and he's going to have an 8-unit rope here. So our circle is going to go all the way around to here, but then what happens when he gets to the corner of that barn? He can still walk, but it's not going to be that full circumference of that circle, aka circumference is like the perimeter of a circle. So when he gets to that corner down here, what's going to happen? His rope is going to get bent as he walks over here. So then his rope is going to bend off here on the corner of that barn, and the same thing is going to happen here. Well, if this side of the barn is 4, then what is the length of this piece of the rope right here? 4. Because 4 plus 4 is 8, and the whole length of the rope is 8. Are you following me? This is 4, and this is 4 as well. Now when he walks, now his circle has gotten a little smaller. Let's think about what the 8 represents in the circle. Thank you, Gary, for answering that question. What does the 8 represent in that circle? Or in that first circle? The 8 is the radius of the circle. Now, if we're going back to vocabulary, in a circle, your radius goes from the center to the outside of the circle. So this is radius. So the corner of that barn right here is the center of our circle, technically. And he's walking around and he's walking around. How much of a circle do I have here? Again, that's a terribly drawn circle. How much of a circle do I have there? 3/4 of a circle. So if I find the area of a circle with a radius of 8, and I multiply that by 3/4, or I divide it by 4 and times that by 3, then that's going to give me the area of that section. Let's start there. So I have area of the 8. equals. I always label what I'm doing when I'm doing formulas like this so I don't get lost. Remember, area of a circle equals pi r squared. Now, when I look at my answer choices, all of my answer choices are in terms of pi, which means I don't have to figure that out. If they wanted you to approximate that, because remember, pi just goes on forever and ever and ever. If they wanted you to approximate that, then we would be looking at 3.14, but they would define that for you in the problem. So because they're all in pi, I'm literally just going to write pi times r squared. 8 is my radius of this circle. So I have 64 pi is the whole circle. Now, for some of you, it makes sense to multiply by 3/4. For others of you, it makes sense to divide it by 4 and multiply by 3. You're doing the same thing. So this equals 64. I'm going to multiply it by 3/4. And when I multiply it by 3/4, I get 48 pi. That is the yellow section. Now I have to find the area of these smaller circles, or these smaller portions of circles. And what am I going to do there? Because they're still circles. We're going to use 4 as our radius here. So y, let's zoom in again. Now this is becoming the new center, and I have 4 as my new radius, and now he's walking this way. I hate it when that happens. All right, I'm reconnecting. Sorry, guys. Okay, isn't it a circumference problem? Thank you, Gary and Joseph, for being like my question answerers tonight. I really appreciate it because I'm just rolling with with working this problem out. I hope it makes sense. We're asking for area, but I really am glad that you asked that question, because I would love to do a circumference problem. Rebecca, that's a really good question. Okay, I'm over explaining it. Every problem that I do on these types of nights, I solve myself. So you'll notice I've got my scratch work here. When I solved it myself, I solved it in probably 90 seconds. I'm over explaining only so that everybody in the room can benefit from this problem. But this problem really can be done in 90 seconds because once you draw your picture, area is, I'm glad you need me to over explain. Area of a circle is super straightforward, pi r squared. So once you realize that this is 3/4 and then these are each quarters, you can pretty quickly solve that. The problem is when you get to a problem where you don't understand the problem, and so you're having to spend extra time processing the problem. And so tonight we're just processing it. This must be high school math. It is high school math. You're absolutely right. Okay. I love how much you guys are talking and interacting. That makes it way more fun for me, to be quite frank. Okay. So green parts, those are just quarters of a circle. Like if we draw a circle and we look at that, these little pieces down here are just quarters. So, but what does 2/4 equal? A half. So now when I find the area of the radius of 4, I'm going to do area equals pi r squared. That's not 4 times 2, people. That's 4 squared, which is 4 times 4, which is 16. So this is 16 pi, but remember, that's the whole circle. So now I need to divide that by 2, which gives me 8 pi, because the 2 green pieces ultimately make a half of a circle. Now all I have to do is 48 pi plus 8 pi, which equals 56 pi, which is C. For the radius, 8 is 4 times 2. Yes. So if I had a whole circle, then the radius would be 8 and 8. But because that radius is getting chopped in half at the corner of the barn, it becomes 4 plus 4, or 4 times 2. That is correct. All right. Now, Hope asked, what if this was a circumference problem? Like, what if they asked, what is the, like, if they wanted to fence in the fence line, which would be a super weird fence line, but like, what is the circumference, or what is the perimeter of the area that this goat has access to? You would follow the same protocol. Except we would use the circumference formula, which is 2 times pi times r. So we would still divide it by, or times it by 3/4. We would still divide it by 2. We would still be looking at the same picture. We just, instead of looking at the inside, we would be looking at that perimeter piece, but you would follow the same protocol. In fact, I'm going to put a little star next to this, and we'll work out the circumference of that next week. I don't want to talk about this goat any longer, so we're not going to do that right now, but we'll do that next week. All right. Let's jump to a problem for my elementary people. The next couple problems are log problems. And so those are definitely more high school based. And I want to do an elementary problem. Thanks, Eddington. That really means a lot. Appreciate it. All right. Heather went out to dinner. And Gary, you make a really good point. So yes, it's important for you to know your exams study companion is what Praxis calls it. Blueprint is what FTCE calls it. It's important for you to know what your test is testing, because some middle grades, 5 through 9 is what most of them are, may require you to know the area of a circle and the circumference of a circle. If it says to know the area of a circle, that problem would be fair game, because all this is area of a circle. It's just a complicated area problem, but all it's asking for is area of a circle. So if your blueprint or your study companion says that you need to know area of a circle, or just area of shapes in general, this would be a fair game problem. Now, elementary people, this is not going to show up on your test. I can promise you that, even if you need to know area of a circle. But middle grades, this would really be a fair game if it asks you to find area of a circle. All right. Heather went out to dinner with 3 friends. The bill before tax and tip cost $184.32. The tax applied to the bill, 6.5%, and they decided to leave a 22% tip after tax. If they decide to split the bill evenly, how much did each person spend? All right, again, this problem, if I solved it normal, wouldn't take too long, but I'm going to explain through it because that's really why we're here, right? Okay, so we know Heather went out to dinner with 3 friends, and they want to know how much did each person spend. Well, if they want to know how much each person spent, how many people are at the dinner table? 4, not 3. There are 4 people at the dinner table, not 3 people at the dinner table, because of Heather and her 3 friends. So if it's Heather and her 3 friends, we are splitting the bill evenly with 4 people. I'm going to look at that right away because I don't want to make that silly error in the beginning. And a lot of people are going to divide the total bill by 3. Now, let's solve it. If the total bill before tax and tip is $184.32, and the tax is 6.5, and they decided to leave a 22% tip after tax, I'm going to solve, thank you, Joseph, I'm going to solve the percentage of tax first. So I'm going to multiply this. I have 6.5%. How do I transfer a percent into a decimal? I'm going to hop that decimal 2 places to the left. So no matter where the decimal is, if I have 12%, 5%, 6.5%, and 122%. I'm going to show you how to transfer all of these into decimals because people get super confused. So if I have a decimal that I'm hopping, If there's no decimal visible, it's imaginary at the end of the number. So I'm going to hop 2 places, and this equals 0.12. I'm going to hop 2 places, and this equals 0.05. Common mistake is people put 0.5. When I hop 2 times and there's an empty hump, a 0 goes there. I'm going to hop 2 times. I have an empty hump, so a 0 goes there, and that equals 0.065. It does not equal 0.65, which is a common error. And 122%, the decimal is right here. I hop, and it equals 1.22 as a decimal. That makes sense because the percent is greater than 100, and so my decimal should be greater than 1. All right, so I'm going to multiply this by 0.065. Now, this problem has the potential for landing on a middle school or high school exam where you have a calculator, on a GK where you have a 4-function calculator, or on an elementary exam where you have no calculator. I'm going to use my calculator for the sake of time tonight. However, you don't have to use a calculator, or if you don't have a calculator, you would have to do it by hand. I said you don't have to use it. I don't know why you wouldn't if this was your problem and you had a calculator. All right, $184.32 times 0.065. Please make sure you type the 0 into your calculator, and you don't assume that when you do 0.65 that 0 counts, because that 0 is to the left of the decimal, not the right. Okay, $184.32 times 0.065 equals $11.98. What does that number represent? You have to know as you're going step by step what each number represents. That number is the tax. That's not the total, that is the tax. So I'm now going to add the tax in to the 184. So when I add that tax back into my bill, I have $184.32 plus $11.98. Plus $11.98. And again, I'm going to use my calculator because I can, and I don't want to spend forever on this problem. That equals $196.30. Now what am I going to do? Multi-step problem here. They love multi-step problems. Absolutely, Jacinth. It is for people. Excellent job. I love that you noticed that. Okay, now that I have $196.30, I'm now going to look at my tip, which is 22%. What am I going to do? Hop that decimal 2 places to the left and multiply by 0.22. 196 times $0.30 times 0.22 equals $43.18 with 6/1000ths of a cent. So we're going to round that off, and then we're going to add it to the $196.30, which equals $239.49 when we round it off. Oh, goodness. Would you look at that? None of my answer choices allow me to split the bill evenly. The answer choices are all totals, and I did not split the answer choices into even chunks. I bet that's why Jacinth was asking that question, because she was probably ahead of me. So this is your total bill. And all of my answers are my totals. So we're just going to go, oh, that's not what I wanted to do. We're going to go, now I'm going to take that and divide it by 4. So $239.49 divided by 4 equals $59.87. So each person is spending $59.87. Sorry about that, Joseph. No wonder you were so confused. So, Gary, you're my high school person over there. Doesn't have to be multi-step. I could technically argue that that is still multi-step because you're having to do multiple operations. So you're multiplying twice and then dividing. So technically it's still multi-step because you're doing multiple operations. But no, if you can recognize that, then no, it doesn't have to be multi-step technically. Now, if you notice what Gary said, he's multiplying by 1.22. That's a little trick. So if I take the $196.30 and I multiply it by 1.22, what I'm basically telling this decimal is I want to do 22% of this bill, but I also want to include the whole bill in my answer. So when you multiply those two together, you end up getting $239.49. But if that's, I don't like doing it that way. I don't know why. I like to do extra work. I always multiply it by 0.22 and then add, but some people do like to do it like that. Why do I divide by 4 for this problem? Because it asks us here if they decide to split the bill evenly. So I have to divide the bill by all the people who are sitting at the table because one person is not picking up the tab. They're sharing the bill. It's like when the waitress says, is this going to be on one check or separate checks? That's why. All righty. Let's go ahead and switch over to another high school problem, and then we'll go back to elementary problems to finish off. So, solve log of x of 4x plus 5 divided by 6 minus 5x equals -1. So we have a base of x. We're operating the log here, and it all equals -1. How are we going to solve this? I don't want you to get overwhelmed by the fact that we don't have a base number here. That's okay, and it's actually going to work out in our favor. I'm trying to get x by itself. That's what you need to remember in this, x by itself. How are you going to get x by itself? Well, somehow I have to get rid of that log. How do I get rid of log? Well, let's start here. How do I get rid of addition? Subtraction. How do I get rid of multiplication? Division. How do I get rid of an exponent? Square root. How do I get rid of a log? I am going to totally not use a mathematical term right now. You're going to big number it. That's a terrible way to say it, but you'll see what I mean here in a minute. So when I get rid of this, I'm going to make the log an exponent, which is why I'm calling it big numbering. I'm going to big base this log. So if I do x to the log of x to the 4x plus 5 divided by all of that, power. This became my exponent. Then what happens is all of the log disappears. So now I have to do this as well, where -1 becomes my exponent. So I'm just left with what's inside the log. I'm left with 4x plus 5 divided by 6 minus 5x equals x to the -1 power. Now, what do I know about a negative exponent? A negative exponent just means I can put it on the bottom of a fraction and it becomes a positive exponent, or vice versa. If it's a negative exponent on the bottom and I move it to the top, it becomes a positive. So this can become 4x plus 5 divided by 6 minus 5x equals 1 over x. What can I do now? Cross multiply. Very simple. If I cross multiply, I can solve. So I have x times 4x plus 5 equals 1 times 6 minus 5x. Well, you and I both know that 1 times anything is just itself. So this becomes 6 minus 5x. And this, elementary people, here's a little tidbit for you. I'm going to distribute the x through. So I get 4x squared plus 5x. Now I immediately notice I'm dealing with a quadratic. Because I'm dealing with a quadratic, I have to solve it using quadratics. So now we're going to continue on up here. I'm going to move this stuff to the other side. So my arrow's a little bit too big. 4x squared plus 5x equals 6 minus 5x. I'm going to add 5x to both sides. And I'm going to subtract 6 from both sides. So now I have 0 on the right, and I have 4x squared plus 10x minus 6 on the left. So I don't like to deal with quadratics that have a big number in front of that x squared. So I'm going to divide out as much as I can. So I'm left with 2x squared plus 5x minus 3 equals 0. I'm going to try to factor it. The quadratic formula works every time, but it allows for a lot of computation errors, and I just don't like to complete the square. So I'm going to try to factor this. 2 and x, 3 and 1. 3 times 2 is 6. 1, that equals 5. So 2x squared plus 6 minus 1, okay, equals 0. Now, remember, I'm trying to find x. So I'm going to bring this up here because I've run out of room again. So this 2 all of a sudden becomes not useless, but I don't need it to solve this right now. I have 2x minus 1 equals 0, and I have x plus 3 equals 0. Subtract 3 from both sides, x equals negative 3. Add 1 to both sides. 2x equals 1, x equals 1/2. I notice that I have 2 answers. However, I also know that a log cannot have a base of a negative number. So x equals negative 3 is automatically out because I cannot have a base as a negative number, which means x equals 1/2 is the correct answer. All right, let's jump back over to some elementary problems. So this looks like a good one. A first grade teacher is teaching a unit on time. Which of the following skills is appropriate for first grade students? So this is obviously for my K through 6 people or my pre-K through 3 people who are taking that exam. So this is one of those problems. You just have to know your state standards. So you have to know if you're taking the FTCE, which this problem came from a practice book from the FTCE, that the Florida standards or the best standards say that first grade students shouldn't be able to tell time to the nearest blank. Second grade students should be able to tell time to the nearest blank. If you're in Texas, you're going to want to look at your standards specifically to be able to answer this question. Especially if you're taking a K-6 exam, they tend to like to ask these kinds of questions in that like teaching pedagogy standards kind of competency. So in the state of Florida, and I'm going to write Florida up here really big because I know the Florida standards like the back of my hand. And so I'm going to answer this question from the perspective of the state of Florida. I think it's very similar across the United States because the set of standards we had before were adopted from Common Core. And so a lot of states have similar standards. But first grade students should be able to tell time to the nearest hour. They also should be able to tell time to the nearest half hour, but that is not an option. And so in this case, it's telling time to the nearest hour. Second grade has to be able to tell time to the nearest 5 minutes. And third grade has to be able to tell time to the nearest minute and be able to do elapsed time. Let's take a look at another one. I already answered this question. I didn't realize I had them back to back. So again, in the state of Florida, we already answered this. Second grade is going to have to be able to tell time to the nearest 5 minutes. So if you're taking an exam, it's good to just quickly review your benchmarks so that you can answer the appropriate questions for like the teaching competencies. All right, we have time for one or two more. So let's go with this problem. Write the equation in point-slope form for a line that passes through the point -3, 0 and is perpendicular to -2x plus 5y equals 20. All right, because I see point-slope form right off the bat, I am automatically going to run to my answer choices and X off anything that's not in point-slope form. If you don't know slope-intercept, standard, and point-slope form for linear equations, you need to know it if you're taking GK, practice core, middle school, or high school. So this is in slope-intercept form. Slope-intercept form says y equals mx plus b. So A is out. All the rest of them are set up in point-slope form. Point-slope form is y minus y1 equals m times x minus x1, where m is your slope and x1, y1 is a point on your line. So I need a point-slope form line that goes through this point. So I'm already going to set my equation up. Y minus y1 equals m times x minus x1. Why did that become a positive? Because the original equation is a minus sign. And because the x value in my point is negative, I'm going to write m times x minus x1 because this is my x, and what does a negative times a negative make? A positive. So because of that, it becomes a positive 3. Right there, I already know what my answer is without even finding the slope. What's my answer? D. Because y minus 0, that's the only one with y minus 0, and it has x plus 3. Now, how do I find my m? Well, I'm going to put this in y equals mx plus b form. So -2x plus 5y equals 20. Add 2x to both sides. 5y equals 2x plus 20. Divide both sides by 5. And here I am with the wrong answer again. Y equals 2/5 x plus 4. So really, my slope should have been -5/2. Because for it to be perpendicular, my slopes have to be negative reciprocals of each other, which means that if the slope of one line is a over b, the slope of the line perpendicular to that is going to be -b over a. So here's my slope. I'm going to flip it and negate it, and that's going to be my slope for my perpendicular line. For upcoming sessions, could you work on problems finding specific numbers in a sequence or series, the 120th number in the series? Yes, and binomial expansion with Pascal's triangle, yes. I will add those both to my upcoming sessions. So let's add a page. Anybody else have anything else you want to see? I'm going to turn it over to Dr. A. We have run out of time. Upcoming series, 120th term, and binomial expansion. Hey, come say goodnight. Okay. Anybody else have anything they want to see? I am going to turn it over. Sorry, I was yelling at my husband to tell me to let me say goodnight to my son. All right, I'm going to turn it over to Dr. A, and he has a special message for everybody. You're welcome. If you have any questions, feel free to reach out to me on Facebook, and I can help you with that as well. I'm going to turn it over to Dr. A, and I will see you all next week as long as we don't have a hurricane come through.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions that I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you the coupon code, all capital letters, SINK35, that's SINK 35. That will take off 35% off any of our prep courses on our website at the Learning Liaisons. Doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.